Hi everyone, this is the last topic from Module E, which is modulus equations and inequations. So the first question, we have to find the value of x for the following equation to hold. So whenever you are dealing with modulus, there are always two cases that you will have to solve for. That is, whatever inside the modulus is either positive or is either negative. These are the two assumptions you will have to make and solve for the cases respectively. So let's do that. First case, whenever we are assuming x as positive, we will take it out as it is without changing the sign. So the equation becomes 3x minus 5x is equal to 8. And when we assume whatever inside the modulus as negative, we'll take it out after changing the sign. So the equation will be minus 3x minus 5x is equal to 8. When you solve both these, you will get two values of x. X is either minus 4 or x is either minus 1. Now don't mark any answer because there is a very important check that you need to make before you mark the final answer. So even though you will see that both the options are present, don't do that because the last check is very critical. So what is that last check is about? So for the first scenario, if you observe, you assume that x to be positive, and when you solved, the value of x that you are getting is minus 4, which is negative, which is contradicting the assumption. And only because of that reason, this is the value that we need to discard. But for the other case, you assumed x to be negative and you got it to be negative, and that means it is in sync with the assumption that we have made earlier. So only one value will satisfy, and hence we will mark answer option 1 where x is equal to minus 1. We cannot take x is equal to minus 4 even though we have solved and got it, but because it is not in sync with the assumption that we made earlier. So this is that last check which I was talking about. So you need to be doing this and only then marking the relevant answers. Second question, you don't even need to solve this because if you simplify this further, obviously this plus 7 on this side will go on the other side and it will be minus 7. So 7, when you subtract from 3, you will get the value as minus 4. And if you remember the definition of modulus, how did we define modulus? Distance of x from origin. And that distance is turning out to be minus 4. So can the distance be ever negative? Obviously not. And only because of that reason, if you're smart enough to pick these kinds of fundamental clues, you will realize the answer in no time without much effort, which is distance can never be negative, and hence no such value of x will exist which will satisfy this modulus equation. So the first couple of questions are very basic. Let's add a layer to that by introducing one more modulus. Now this is where it gets interesting. There's a specific approach that we are going to follow as far as modulus equation inequations are concerned for all these cases. So what you do is, first of all, consider the 2 points on the number line. So the 2 points on the number line are 4 and 10 respectively. And what you do is you find out the actual distance between those 2 points. So when you do that, what you end up realizing is that between 4 and 10, it is 6 unit ka distance. Between 4 and 10, it is 6 unit ka distance. And now what we will have to do is we'll have to start solving the cases respectively. So for example, the first condition, we are assuming that x is between 4 and 10. So whenever x is between 4 and 10, what we will have to do is assume a value. Matlab, when you solve for modulus, if you see the position of x, it is on the right side of 4 and it is on the left side of 10. So whenever this thing happens that the value of x or the position of x is on the right side of some number and on the left side of other number, so to whoever it is right of, you will take that as positive, and to whoever it is left of, you will take that as negative. So because it is on the right of 4, so x minus 4 will take it out as positive without changing any sign. But because it is on the left side of 10, you will take it out as negative with changing the sign. Solve this. X minus 4 plus 10 minus x is equal to 16. When you solve that, what you realize is that x is getting cancelled only. So that means no such value of x between 4 and 10 is possible. Then the other position that x can be at is beyond the 10. So because it is on the right side of both the numbers, so both the numbers will be considered positive and they will be taken out as it is outside the modulus without changing the sign. So now you solve for this. X minus 4 plus x minus 10 is equal to 16. When you solve for this, the value of x that you get is 15. The value of x that you get is 15. So yes, we assume that x is more than 10 and we are getting 15, and hence it satisfies the assumption. So the first value of x that will satisfy this is 15. After that, same thing will be repeated when we assume x to be less than plus 4. So because it is on the left side of both the numbers, so both of them will be assumed as negative and they will be coming out after changing the sign from the modulus, as you can see on the left side. Again, when you solve for this equation, you get the value of x as minus 1. If you remember, you had assumed it to be less than 4. Obviously, minus 1 is less than 4. So this value also satisfies. So both the values, x is equal to minus 1 or x is equal to plus 15, these are the two values that will satisfy this equation. And this is the solving method that you need to be knowing as far as these all questions are concerned. Obviously, there is even more better than something, but this method is something that will be useful in one category of question where the shortcut doesn't work, and hence you need the solving practice for exploring and so simplifying these types of equations very fast. Another approach to do the same, as I said, take the points on the number line in the ascending order, which is 4 and 10. Take their distance, which is 6, and the actual given distance is 16. Take the difference, which is 10, and whatever is that difference, divide that difference by number of modulus. So there are two modulus. So 10 divided by 2 is 5. So what you are going to do is from the respective endpoints, go 5 units on either side. So from 10, if you go 5 unit ahead, you will get plus 15. And from 4, if you go 5 unit behind, you will get minus 1. So minus 1 and plus 15, same two answers for the third question. Shortcut approach. Fourth one, again two moduluses. What you will do is same thing. Points on the number line will be minus 5 and plus 7. Minus 5 and plus 7. When you understand the distance itself is 12 unit between minus 5 and 7. And the actual distance given between the 2 points is 10. And the moment you go beyond minus 5 or plus 7 on either sides, obviously you would understand that the distance will be more than 12, which can never be 10, and hence no such solution exists. So what this question tells you is very important, that the actual distance between the 2 points on the number line has to be less than the distance that is given in the question, because only and only then you can take the difference and then divide by the number of modulus and etc etc. Without this, if the actual distance is more than the distance that is given, no value of x will satisfy that. Remember that as a important pointer. Fifth one, 3 modulus. Approach is slightly different but more or less same. Points on the number line in the ascending order, which is 1, 2, and 3. The part when it comes to now, whether it is 3 modulus, 4 or 5 or more than anything, more than 3 or more than 3, this approach remains the same. So what it tells us is you find the value of expression at the extreme points one by one, obviously. So let's substitute the first extreme point, which is x is equal to 1 in the original question. So when you substitute x is equal to 1 in the original question, the value that you get is 3. But the given value is 12. So again, you take the difference, which is 9, 12, and 3, and divide by number of modulus. So when you divide by number of modulus, what you get is 3 as the sir, what you are going to do is from that point go 3 unit behind. So from 1 we'll go 3 unit behind and we'll get -2 as the answer. Same process has to be repeated for the other extreme point. So other extreme point is 3. Substitute 3 in the original equation. When you do that, again what you end up getting is the value 3. Again take the difference between the given value and the value that you have arrived after substituting 3 in the original equation. Again the difference is 9. Again divide that difference by number of moduluses, which is 3. 9 divided by 3, again 3. So from 3 you are going to go 3 units ahead, which will give you +6 as the answer. So either x is equal to -2 or x is equal to +6. These are the two values of x that will satisfy this equation. So option 2 for the fifth one. Similarly is the sixth one. Points on the number line in the ascending order 1, 4, 5, 10. Substitute the extreme values in the original expression. So let's start with x is equal to 1. When you substitute x is equal to 1 in the original expression, the value that you get is 9 plus 6, that is 16. 9 plus 7, sorry, is 16. The given value in the question is 20. Take the difference, 16 and 20, the difference is 4. Divide that difference by number of moduluses. There are 4 moduluses in the question. So 4 divided by 4, you get 1. Now, what you will do is from 1, you will go 1 unit behind, which gives you 0 as the point. Same process has to be repeated for the other extreme value, which is x is equal to 10. When you substitute x is equal to 10 in the original expression, you will get the value as 20 itself. And the difference between the original value and the given value is 0. That means from 10 as a point, we don't need to go anywhere ahead. We just need to stay then and there itself. So the second value of x that will satisfy this in equation is x is equal to 10 itself, because the difference was 0. So x is equal to either 0 or x is equal to 10. These are the two values that will satisfy this modulus equation. So that's the only difference when it comes to more than two moduluses compared to when you have two moduluses. Approach is slightly different. Seventh one, two new things. So far, we were doing all the questions equal to something. Now they have just added greater than part. So greater than, if you remember from E2, we were going beyond the range. That idea will remain the same. And second part is the option. So this is a bit of technicalities. Now you need to remember this for the long-term process, that whenever they say round bracket something, that implies that the extreme values are not included. So for example, the first option says -1 and 2 round bracket. So that means -1 and 2 is not included. That means the values will be included are 0, 1, that's it. And similarly, when we talk about, let's say, square bracket or curl bracket something, then that means the extreme values are also included in the range, basically. So that's a technical point that you are supposed to remember going further. So round bracket extreme values are not included. Square bracket or curl bracket, the extreme values are included, basically. So let's start solving three moduluses. The process remains the same. Points on the number line 1, 2, 3 in the ascending order. Find the value of the expression at the extreme values. Let's substitute x as 1. When we substitute x as 1 in the original expression, you will get the value as 3, but the original value is greater than 3. So when you take the difference is also more than 3. Divide that difference by number of moduluses, which is 3 moduluses. So anything which is more than 3, when you divide that by 3, the answer will be slightly more than 1. If it is 1, then from 1, you will go 1 unit behind and you would have marked 0. But here, the actual value is not equal to 1 after the final division. It is slightly more than 1. That tells us that we need to not stop at 0, but we need to go beyond 0, because at 0 the distance is 1. When we go beyond 0, only then the distance will be more than 1. And this is that technicality you need to understand as far as the moduluses are concerned, or the inequations are concerned. Same process has to be repeated for the other extreme value, which is x is equal to 3. So when we substitute x is equal to 3, what will happen is, again, the original expression will give you 3 as the answer, but the actual value given in the question is more than 6. So the difference of two of them will be more than 3. Again, divide by number of moduluses, which is 3. The answer is again more than 1. So from 3, when you go 1 unit ahead, you'll get plus 4 as the point. But at plus 4, the distance will be 1. We don't want 1. We want more than 1. So we need to go beyond 4. So beyond 4 when we go, that is only when we'll get the distance which is more than 1. So x is less than 0 and x is more than 4. These are the two values that will satisfy. That was the first trickery of this question. The second part that you need to be careful is the idea of the brackets, which I cleared in the beginning part of the question itself. So when you remember that, and now when you think of both the things together, the option that will satisfy this values of x are is option 2, that round bracket minus infinity to 0 union 4 comma positive infinity round bracket. So that means 0 and minus infinity and plus 4 and plus infinity are not included in the range. Anything which is in between them is included, which is the correct representation of this answer. So option 2 with the technicality of the brackets part. The eighth one, when you observe again very clearly, what is the difference that you note is that the coefficient of x is not 1 anymore. It is some number which is more than 1, which we have not done so far. All the questions, if you see that we have done so far, they are all having coefficient of x as 1. So this is your identification to identify a specific type and what to be done here. What is to be done here. So for example, as I said, if you remember in the third or the fourth question, that there are a certain category of question where that shortcut that we are discussing never works. And this is exactly what it is. So these are the type of questions where the coefficient of x is more than 1, is where the shortcut approach doesn't work. And that is where you need to solve it properly by your typical lengthy approaches and get the answer. So the first thing that you should do is convert this question into our type by taking 2 common from the first modulus and by taking 3 common from the third modulus. So when you do that, this is what you will be left with. X plus 0.5 and x minus 2 inside the third modulus. Again, same thing, points on the number line in the ascending order, they will be minus 0.5 plus 2 plus 5. Now, because there are 3 values of x, the 4 positions will have to explore. Let's start with the first position of x when x is less than minus 0.5. That means it is clearly on the left side of each of the number. And if you remember what I told you earlier, if the value of x is on the left side of particular number, then that is supposed to be considered as negative while removing the modulus. And when you assume it to be negative, you will change the sign and take it out of the modulus. So all the terms will have to change their sign and we'll have to solve them. So when you change their signs and when you solve them, what you end up realizing is that xx will get cancelled after simplification. That means this is where x cannot be at all. So this value not possible. The other possibility for x is between minus 0.5 and plus 2. That means only minus 0.5 के right में है. That means that only modulus will be positive. But 2 and 5 के अभी भी left में है. So those two will be still negative. We'll have to change their signs and take them out. So this is what you will get. Now when you solve for this, you will get the value of x as 1.5. When you realize we had assumed x to be between minus 0.5 and 2, yes, 1.5 is satisfying the assumption. So that is the acceptable solution. The next position for x will be between 2 and 5. So between 2 and 5, x is on the left side of 5. So only that modulus will be negative. That means we have to change the sign and take it out. And for the other two terms, minus 0.5 and plus 2, we'll have to open them as it is because x is on the right side of that. So this is what you will get when you apply the logic. That is like very layman's logic to remember which one to be positive and which is the one that you are supposed to take it negative. Solve that. Again, the value of x that you get is x is equal to 3. We assumed x to be between 2 and 5. And yes, 3 satisfies that restriction. So that is a acceptable solution. And the last case, when x is more than 5, that means x is on the right side of all the numbers. So all of them to be considered positive. That means just take them out as it is without changing any signs. And again, when you solve for this case, you will realize again all the x's will get cancelled. And that means this is also not a possible value or the solution of x that will satisfy this modulus equation. So two values of x that are satisfying, 1.5 and 3. Question was how many values? Answer is two such values of x will satisfy, which is option 3. And this is how you are supposed to solve these types of questions. No shortcut will help you in this. You need the typical lengthy approach solving, and hence you need to pay attention to that as well along with the shortcut, because you never know what kind of questions we'll be dealing with when it comes to exams. Ninth and the 10th one, similar category, but a very important thought process again to remember as one of its type and the identification. Question is mod of x minus 1 plus mod of y minus 1 is equal to 10. How many combinations of x and y we can have so that x and y are integers? So the idea that you need to remember here is inside the modulus along with x and y, what numbers are there plus minus, that is immaterial. It can be anything. What matters is equal to is what number is there, and we'll prove that. So for example, forget the question for time being and let's just focus on this. Mod of x plus mod of y is equal to 1. Now when you start solving, one case you will consider both of them to be positive, so you'll get x plus y is equal to 1. One case both of them will be negative, that is minus x minus y is equal to 1. Other case x is positive, y is negative, you will get x minus y is equal to 1. And the last case, x is negative and y is positive, so you will get minus x plus y is equal to 1. Four equations, you solve them, simultaneous equations, you will get following four combinations of x and y. 0, 1, 0, minus 1, 1, 0, and minus 1, 0. So what does that tells us is that whenever mod of x plus minus inside of that, whatever the number or anything doesn't matter. But if it is equal to 1, it gives us four solutions. And these are those four solutions when you plot them on the graph. So taking this idea further, suppose we do mod of x plus mod of y is equal to 2. And when we simplify that, you will get 8 different solutions. And these are those 8 different solutions that we have similarly solved based on the graph of the question. So to generalize both the cases, what we can say is inside the modulus with the x and y, what numbers plus minus are present, that is immaterial. What the only thing that matters is equal to is what. So if it is equal to 1, we get 4 solutions. If it is equal to 2, we are getting 8 solutions. And applying and continuing the same logic, in our question it is equal to 10. So for is equal to 10, obviously how many solutions you should get? If you continue the pattern, you should get 40 different solutions. So for the ninth question, option 2 is your answer. This is the way to think about it. Remember this very, very important idea in a different manner. Last bit, mod of x plus 2 plus mod of y minus 3 is less than or equal to 10. How many combinations of x and y we can have? X and y are integers. So again, inside the modulus along with x and y, what numbers plus minus doesn't matter, less than or equal to 10 is what matters. So just now we had seen less than or equal to 10. So suppose it is equal to 10. How many solutions we'll have? We'll have 40 solutions. But if it is equal to 9, we'll have 36 solutions. If it is equal to 8, we'll have 32 solutions and so on till 1, and we'll get 4 solutions. Now, how do we will add all of this starting from 4, 8, 12, so on till 40? Arithmetic progression. SN ka formula, sum of first n numbers of a AP. These are the interconnectivity of the topics you should remember. So n by 2, that is 10 by 2, 5. A plus Tn, A is 4, Tn is 40, 4 plus 40, 44, 44 into 5, 220. But hold on, don't mark 220 as the answer, because less than or equal to 10, so 0 is also the integer which comes in less than 10. And for x plus y, I mean mod of x plus mod of y is equal to 0, there will be one solution which is 0 comma 0, which is origin, that we cannot forget about. This is the part where you need to be very careful with the technicalities. A lot of people, even if you can able to understand and get this answer, you will still mark 220 without even realizing what is the mess that has happened. So 0 का एक solution भूलना मत, 0,0 origin वाला, which makes the final answer as not 220 but 221. Both of them will be present, but 221 is correct, which is option 3. So with this, we are done with the E module, which is first part of algebra. F module is also the second part of algebra. If you have any questions based on this, let us know. Thank you so much.